Hi guys. We've got two more lessons in chapter 3. It's kind of a hodgepodge chapter of a lot of different things. But today we're going to talk about something new. We did not do this last year in Algebra 2. We saved it for pre-calc. And the topic we're going to discuss today is called arithmetic sequences. It has nothing to do with the beginning of the unit, which was on exponentials and logarithms. So it's just kind of a cool side topic that we're going to throw in today. So arithmetic, you may have heard the word arithmetic, which is spelled the same way, but arithmetic is basic math, adding, subtracting, multiplying, and dividing. An arithmetic sequence is a list of numbers that has a pattern that has to do with either adding or subtracting. So we're going to look at lists of numbers and see if we can figure out the pattern and figure out a formula for those patterns. So fancy definition. An arithmetic sequence is consecutive terms that have a common difference between them, forming an arithmetic sequence. Now it says difference, it just means that there's a gap between the two numbers, and it could be a positive difference or a negative difference. If it's a negative difference, it's going down. If it's a positive difference, they're going up. So here's an example. The list of numbers separated by commas with a dot, dot, dot at the end, meaning that this pattern continues. 1, 4, 7, 10, 13. It's very easy to figure out what that pattern is. Even an elementary school kid could probably figure it out, right? So we're talking about going up by 3. So what we do to figure out the formula is we define the difference. That common difference is defined as the letter D. And, well, let's do another one before. This one you can see is going down. They're getting more and more negative, although it starts positive. And from 2 to -3 and -3 to 8, you can see that it's going down by 5 each time. So it has a negative D value. The difference is negative. Now, it gets a little trickier if it's fractions, but of course, fractions happen, so we have to be able to do it. We go from 1 to 5/4 to 3/2 to 7/4. That almost makes you think it's not arithmetic. But let's think about this. From 1 to 5/4. 1 is 4/4, so up to 5/4 would be up 1/4. From 5/4 to 3/2. Well, 5/4 plus 1/4 would be 6/4, which actually does reduce to 3/2. And then 6/4, 7/4. So if you wanted to rewrite this, you could rewrite it as 4/4, 5/4, 6/4, 7/4, 8/4, 9/4. So yes, it's going up by 1/4 every time. Kind of tricky. All right, now here's an example that maybe looks like it's going to be an arithmetic sequence at first, but if you look at the pattern, it goes up by 3, then it goes up by 5, then it goes up by 7. So there's a pattern. I'm not saying there's not a pattern, but it's not an arithmetic pattern where there's a consecutive difference between the terms. So that's non-arithmetic. Okay, so there's actually a formula. It's pretty easy for the nth term of a sequence. 2, 6, 10, 14 is our example. That's going up by 4s. You can tell that D is 4. And if we want to find the 50th term, that would be a lot of adding 4s. So I really don't want to list them all out and keep adding 4. But think about it. Mathematically, if you add 4 49 times, that's 49 times 4. And where did we start this whole sequence? We started it at 2. So the pattern is starting number plus the difference, and then however many times you need to go that difference, sorry. And so if we want the 50th term, we're going to have to add 4 49 times. And that gives you 198 for this particular example, without having to write out all the terms. So in general, the nth term follows this equation. Now these are subscripts, so the A with the little n subscript means the nth term in the sequence we're calling sequence A. The A with the little 1 subscript means the first term in that sequence. So take the first term in the sequence and add the difference to the n, or times the n minus 1. That means you're going to go up 49 times, for example, in the last one, to get to the 50th term. If you wanted to get to the 100th term, you'd have to add the difference 99 times. So it's n minus 1 times D. So the nth term of the sequence equals the first term plus the difference times n minus 1. So for this example, the first term was 2, the common difference was 4, and then you put n minus 1. Now you've got a formula that you can use for any sequence that you want, right? You can use it, I'm going to underline this right here. So you can use it to say, okay, I want to find the 293rd term. So you just put 293 for n. Here is the subscript. Okay, right here is the subscript. And then here you plug in the number 199, if that's what I said. I can't even remember what I said. And you plug it in, 199 minus 1. Sorry, 200 minus 1 is 199. That's what I meant. And then 4 times that, and you'd get your term. Okay, let's see if I've messed this up by clicking on the pointer. Yes, I have. Let me turn that off. Okay, so here's another example. 3, 8, 13, 18. Easy, that's going up by 5s. So to find the 33rd term, we're going to take the difference of 5. We're going to put that into the formula for D, and then n minus 1, general generic formula, starting off at 3. So to find the 33rd term, a sub 33, we take that first term plus 5 times 33 minus 1, which is 163. In general, it would be a1 plus d times n minus 1. Okay, sometimes I will actually give you the formula, and you have to give me some terms of the sequence. So for example, here is, oh, this is not one where I give you a formula, sorry. So I give you the 4th term and the 13th term. So the 4th term being 66, the 4th term being 21, and the 13th term being 66, that's a difference of 66 minus 21. And it took from the 13th term to the 4th term to get there. I said that backwards too. From the 4th term to the 13th term. So this is kind of like finding slope. And it really is. If you're going up by a constant amount every time, it's like a slope. So we do y minus y over x minus x. And that gives us what the common difference is. So the formula this is going back and figuring out the previous terms. So the 4th term we knew was 21. The difference was 5, so we can go down by 5s, we can go up by 5s, we can give as many terms as we are asked to. The question asked for the first 5 terms, so we started with that 4th term of 21 and worked our way back. Okay, let's try another example. The 3rd term is 14 and the 8th term is 34. So in 5 terms it went up 20. So 34 minus 14 over 8 minus 3 gives a common difference of 4. So we knew the 3rd term was 14, count back by 4s and up by 4s to get your first 5 terms of the sequence. Okay, the 23rd term is 12 and the 28th term is 2. This is definitely going down, right? No, wait a second. Yeah, it's going down. This must be a fraction one. So let's subtract. We're going to go 2 minus 12 over the 28th minus the 23rd. We get negative 2. Not a fraction, but a negative number. So the formula is going to be first term plus negative 2 times n minus 1. We want to find out the first term, so it seems too long to count back from the 23rd. So instead we're going to use the formula, plug in 1, plug in 2. Well, plug in 1 first, and then you get the first term, and then you can just add negative 2 to get the rest of the terms for the first 5 terms of the sequence. Okay, now we have one other type of formula that goes along with arithmetic sequences. It's called the recursive formula. And recursive means something that cycles back on itself. So in this type of a arithmetic sequence formula, you have to know the term before the term that you're looking for. This is not very helpful if you're looking for like the 570th term, because you'd have to know the 569th term. But it can be useful if you happen to know the term just before the one that you want. So they look like this. Same style of sequence. This one's going up by 4. The second term is the first term plus 4. And the third term is the second term plus 4, and so on. So in general, we have this formula where to get the nth term, you have to know the n minus 1th term and then add the difference just one time. That just bumps you up to the next one. And then you can find the next one and the next one and the next one. You could even go backwards if you wanted to. But the recursive formula is a little bit harder in my opinion because you have to know the term before. So again, this subscript minus here is not telling you to do anything mathematically. You don't have to subtract 1. It's saying the term before the one that you want. The subscript is just telling you the location of the term. Sometimes people write the recursive formula where they say the next term is the previous term plus d. They just rearranged the order and they changed it to the next term, going back to the previous term. It means the same thing. Okay, so here's a first term, and then we want to find another term after that. So if the first term is 3, we can see that it's going up by 2. So to find the second term, we take the first term plus 2, then we add 2 more and add 2 more. Okay, here's one where the first term is 1, and this time it goes down by 3. So 1, subtract 3, subtract 3, subtract 3, subtract 3. So anytime you want to get a term, you take the term before it and subtract 3. In this first formula, anytime you want to get the next term, take the previous term and add 2. Okay, last formula. And by the way, you are going to get to have a note card for this test so that you can put all this stuff on there. The sum of the finite arithmetic sequences. So sometimes you actually want to not just list all the terms, but you want to add them up. So that's called the sum of a finite, meaning a limited group of values. You can't add up all the terms because it has no end. That's what the dot, dot, dot means on the end. So the formula for that is a capital S with a little subscript of n. That means it's telling you how many terms you want to add, like the first 10, the first 20, the first 50. And then I think this is the coolest formula. All you have to do is say how many terms you're going to add, that's n, and then you have to know a sub 1, which is the first term, and then the last term in the list. And basically all you do is average them and then multiply by n. I always thought that formula was so mysterious, but it actually makes sense. So first, 100 positive integers. That means 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 100. I want to add those numbers from 1 to 100. Formula says take the number of terms you want to add, which is 100. The first term and the last term, 1 to 100, I want to add them all up, divided by 2. So that's 101 divided by 2 times 100. It's 5,050. That's what you'd get if you add up the numbers from 1 to 100. All right, here's another list, 1, 4, 7. They're going up by 3s, and the first term in the list is 1. The last term in the list is 28. But how many terms are there between 1 and 28 if you're going up by 3s? Well, 1 from 28 is 27, and we're going up by 3s. Divided by 3, we get 9. But you know what? You don't even have to know that. You don't have to know that. All you have to know is the first term and the last term and how many terms you're adding. Oh, I said 9. 9 times you have to add d, but that means there's 10 terms. All right, 145 for that one. Okay, sometimes you might see this Greek letter S instead of the capital S. It means the same thing, and I kind of like the way it works because it says you want to find the sum. It's a sigma, it stands for sum, from n equals 1 to 56. So they put the lower number on the bottom and the upper number on the top. From the 51st term to the 56th term. So that's 56 terms. So the formula, we're going to put 56 for n. And then the first term is, well, what is the first term? We're going to have to plug in 1 to find out. 5 times 1 is 5 minus 2 is 3. That's how come the first term is listed here as 3. Okay? The last term, the 56th term, 5 times 56 minus 2 is the 278. So that's where those two numbers came from. Okay? So we're going to add the first term, the last term, divide by 2, and then multiply by how many terms there are, n, which is 56. So that one turns out to be 7,868. Okay, 150 terms. Now this is tricky because we don't know the 150th term. So our first job is to find the 150th term. So the first term we can see is 5. We can see that they're going up by 11 every time, so that's D. And then the number of the term we want is 150. So we do this little formula here and we find out what the 150th term is. Now we can do the partial sum. There's 150 terms, first term, last term divided by 2. It's a cool formula, and I know you can't see the answer because my picture's blocking it, but it's there. All right, I hope you found this to be an easy lesson. Please come to office hours if you need any extra help, and I will see you soon. Bye.